Alright, so today it's day 59. I did 3 lead code mores, which was these 3 ones: Coco eating bananas, minimum rotated sorted array, and searching rotated sorted array. We are at 25 total out of 150. Let's redo them very quick. Let's start by this one. So we have like an amount of piles, right? And we gotta find a number k, which is the rate at which Coco eat bananas, and we have like some time. So I don't know, if the rate is 4, the first pile she can eat it immediately in 1 hour, so it's gonna be 1. Then this one is gonna take 1 hour because it eats 4 bananas at a time, and there is 4 bananas, and so on and so on. So the first thing that we gotta do is gotta like compute a function that for a given k, I'm gonna call it time k, it computes the time it takes to finish the bananas. So it takes into account piles and k, and it returns the sum of every p divided by k, but this p is like truncated up. And for p in piles, then we can use let's initialize the left and the right pointer. Here we are understanding the speed as the array, like the element where we are searching, and the minimum speed is gonna be 1, right? That's the minimum rate, and the maximum, it's gonna be the maximum element, because it doesn't make sense to have a higher speed than the maximum element, because we want the minimum k. So if you have a rate higher than the maximum element, you are not decreasing. We want like the minimum, like it doesn't change the time it takes. So it's gonna be max of piles, and we're gonna have a while loop, while left less than right, we compute mid, which is gonna be left plus right divided by 2. And then let's compute the time. So that the time it takes, it's gonna be evaluating the function at the time mid, and then we check if the time. So here we have like two. The main condition is we want to know if the current k that we computed, which is like an average k between like the smallest and the highest possible value, it makes sense, like it satisfies the constraint that says that we are finishing the bananas. And to finish it, and if we have some sort of time to finish the bananas, we have to have a smaller time than the time they give us. So it has to be less or equal than h. So if it's less or equal than h, it means that we finished the banana. But now we want to check if we can finish the banana even in a smaller time, and at with a smaller speed, because many speed, there are different speed that can yield the same time. So here we want to make k smaller, which is the speed, right? So to make k smaller, if we imagine k as an array, we computed like some mid value. If we want to make it smaller, it means that we need to move the rightmost pointer into the position to where it's mid now, taking into account that mid eats directly. We want to take into account in the next iteration also. So it's gonna be right equal mid. Otherwise, by the same logic, we want to move left, and it's gonna be also mid but plus 1, because it means that the current mid does not satisfy, so we can check to the right of it. And then once we finish, left and right, they're gonna have the same position, so we can return directly left. And there is an error. Okay, good. Accepted. Okay, next problem, which is find minimum in sorted array. So in this one, let's do it again. The main intuition in this one was, what was this problem? Find minimum in sorted array. This problem, I believe, you need to separate it into, I mean, for me it was like, you evaluate whether the array is like a good array. So basically, let's initialize again the pointers, 0 and length nums -1, and we can check if it's like a good array, because if it's a normal array, the minimum value, it's gonna be the first element. So if it's good, we're gonna return the first element. Otherwise, or we can do it like this. If it's not good, we're gonna perform a while loop, right? Otherwise, we're gonna return nums. It's index? No, we gotta return the number. Yeah, so it's gonna be nums L. So we can say that if it's not good, it means that, by not good, I mean it's not sorted in the way, like in a standard way. So it means that nums is greater than nums L is greater than nums R. And now we can do the while loop. While left this thingy, left less than right, we're gonna compute mid, left plus right divided by 2. We're gonna have like some value, which is gonna be nums of mid, just to make it more explicit. And then we gotta check if the value, let's see, so if this value is greater than the right side, so it's 6 greater than 2, it means that we need to move the left pointer all the way to where the 6 is now. So if val is greater than nums R, we're gonna move the left pointer to mid. Otherwise, we're gonna move the right pointer to mid. And if it's smaller, okay, now let's think about it, because sometimes you need to add +1 -1, something like this. So if you have val, let's say the mid value is 5, we ask ourselves 5 is greater than 2. In this case is yes. So now left, it's gonna be this one, this value. The next iteration, we have 5 and 2. We're gonna have this value, and we are gonna ask ourselves, is 6 greater than 2? Yes. If val is greater than nums and we want to return the minimum, we can check directly in the next value of val. And that's it. Good. Alright. So, last question. The last question is search it in a search in rotated sorted array. So in this one, let's see, you're given an array of length n. In ascending order, it has now been rotated between 1 and n times. But now, instead of getting the minimum value, we are gonna return some target. Okay. So the intuition in for this problem was, you can consider whether the left side, you can decompose the array into 2 arrays, and you can think if the left side or the right side it's already like sorted or not. So if we want to search the one here, we would take mid, which is going to be 5, and then we would check if this is sorted from 3 to 5 or from 6 to 2. In this case, the left side is sorted, and then we ask ourselves if the target is within the first half or the second half. In this case, in the second half. So we would move this to the, we would move the left pointer to mid. That's it. And what happens if it's like a normal array? If it's a normal array, we would have mid, and we would say the left side is sorted. I think it doesn't matter. Okay, let's do it, and then we can think about it. So it's between nums, the list is nums -1 while left less or equal than r. In this case, it could be that there is no, it doesn't find it, right? Okay. We compute we're gonna ask ourselves if the left side or the right side is sorted. So if, okay, let's compute mid first. So it's gonna be left plus right over 2, and then if left is less than, if nums left is equal, that's the first thingy we gotta check. If it's equal to, wait, if nums mid is equal to target, because it means we find the value. So we gotta return the index, or what? The actual for, yeah, the index. So we're gonna return mid. Otherwise, we need to check how are both arrays sorted. So let's ask ourselves first, the left array could be the one sorted. So you can say if nums left is less than nums mid, it means that this is sorted, otherwise the right side is sorted. So if left array is sorted, now we have to ask ourselves if we need to move, if nums, if the target is within the array. So we gotta ask if nums L is greater, equal than target, which is greater or equal than nums mid. But wait, the mid, we're not evaluating mid here, but here, so we can remove this. And if this is the case, it means that we need to move the right pointer to where mid is -1. Otherwise, it means that we need to move the left pointer let's think about it. So if this is sorted, let's say this is mid, we ask ourselves is target, which is 1, between here, and you're gonna say no. Alright, so you're gonna move, I mean in this case it's yes, but if it's no, you're gonna move left to mid +1. I mean, if it was this number, I think it's like this. And otherwise, you gotta do the same, but when mid is between target and nums right. And if this is the case, if target is in the right side, means that you need to move. Okay, first I need this. If target is in the right side, okay, so this is when the left side is ordered, but when the right side is the one ordered, if the right side is ordered, it's gonna be like a normal, I'm complicating too much. If the right side is ordered, we ask ourselves if target is in the right side. If it's in the right side, means that the left side, we gotta move the left side towards mid, and the right side towards mid plus 1 minus 1, something like this. Okay, there is one issue. Okay, we are not returning anything. Return minus 1. I think I'm missing this. Yeah, I don't know why I didn't include it, but it's okay. Okay, there is one problem. 3, 1, the target is 1. Let's see. Wait, left and right, so it's gonna be these two. And then we ask ourselves if num else is less than nums mid, which this is the case. No. Mid is this. So we gotta check this. Left array. No, what? This should be the case. Wait, I'm getting confused. If the left array is sorted, okay, the left array is sorted, we check this, 1 and 1, I mean it's the same value. So I think it's the top one. Okay. Okay, let's think about it. So it's 3 and 1. Mid is 1. No. I mean 0 and 1, 0 plus 1 divided by 2, truncate it to 0, it's 0. Then mid is 0. Then we check this and this, 0 and 0, which this is not the case. I mean, it technically is. So maybe it's because of that. Yes. Alright. So it was this thingy. I finished the 3 problems of today, and that was it. We're getting there.